The last type of function that we talked about this year, and the last type of function we need to analyze using key features, is going to be an exponential function. The vocabulary words that we need to define for exponential functions are right here. You're going to notice that several of them are very similar to the ones that we've been talking about for the last two videos. The only one that's different is the term asymptote. And remember that your asymptote is where the line levels off. So it's going to be coming down, 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 and then it's going to hit this wall and level off. Or it's going to be coming up, 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 and it's going to hit a wall and level off. Where it levels off is going to be your asymptote. So where the line levels off. And it's always going to be a y value. Good. Your zeros, once again, are going to be your x-intercepts, also known as roots or solutions. Your y-intercept is where it crosses the y-axis. Domain, your x values. Range, your y values. If you didn't know domain and range before today, I hope you do now. Interval is where the function is increasing, is when you're going up. Decreasing is when you're going down. Function notation is when we have that silly f of x. We're going to replace that x with a 2. And then end behavior, and it's not always 2, it's when they tell you that it's 2. Your end behavior is the y values as x approaches infinity. Good. Okay, so let's just jump right in. The first thing I want to do is I want to look at the graph of this in my graphing calculator. So I'm going to go to my y equals. My quadratic function is still in there, so I'm going to clear it out. I'm going to type my new function in. We have 3 to the power of x minus 2. So 3 to the power of x minus 2. I'm going to look at my graph. All right, here it is. To graph this, I'm going to look at my table again. And as you can see, my asymptote is very clearly negative 2. Let's zoom in a little bit. You can see that there's a bunch of negative 2's. That means that it's never going to go below negative 2. It goes above negative 2, but it never goes below negative 2. So let's see. If we start back here at negative 6, 1, 2, 3, 4, 5, 6, it's about negative 2 all the way until it starts going up a little bit here at negative 1, and then it's 0, negative 1, and then you got 1, 1, 2, 1, 2, 3, 4, 5, 6, 7. It barely fits. So this is what your graph is going to look like. You've got, it levels off down here, then it's going to come up, it's going to cross again, like so. So that's what the graph of this looks like. Clearly, we level off down here at negative 2. So your asymptote is going to be at y equals negative 2. You can also see that you have a constant of negative 2 at the end. That is always going to be your asymptote also. So if you ever have a constant after your exponent, so constant after exponential term is always going to be your asymptote. So for example, if you had y equals 5 to the power of x plus 7, that plus 7 would be your asymptote, meaning it's going to level off somewhere up here. Okay, your 0 is your x-intercepts. Your x-intercept is right here where it crosses the x-axis. I'm going to say that's about 1/2. So it goes over 0.5 up 0. So y always equals 0 at the x-intercept. That was supposed to be... Okay, good. Your y-intercept is where it crosses the y-axis. It crosses your y-axis right here, which is clearly negative 1. So go over 0, down 1. It's when x equals 0. Your domain is all of your x values. So if I'm looking at this, it's going to go forever in the negative direction. and it's going to go forever in the positive direction. Your domain is almost always negative infinity to infinity, if you haven't realized that. Again, unless you have endpoints, which we'll talk about in video 5. Your range is going to be a little bit different for your exponential functions, similar to how they were different for your quadratic functions. Notice that my exponential function never goes below this -2. It hits the wall at -2 and shoots off this way. Never does it cross that line. It cannot cross that wall. It's impossible. So my range, because it's above -2, it's always above -2. It's going to be from -2 to infinity. It's going to go up forever and ever and ever. Increasing versus decreasing, I'm going to read it like a book. I'm going to go to the right, and as I go from left to right, I feel my finger always going up. Never am I going down. So it's increasing is all real numbers, or negative infinity to positive infinity. If it's always increasing, that means it's never decreasing, or there are no decreasing intervals. Function notation, so they want me to plug in x equals 2. So my function was 3 to the power of x minus 2. Everywhere I have an x, they want me to plug in 2. So f at 2 equals 3 to the power of 2 minus 2, which would be 3 squared is 9 minus 2 equals 7. You could also just type that straight into your calculator. If you do 3 to the power of 2, or 3 squared minus 2, you get 7. So using your calculator rather than your head is the very best way to do any problem when you're given the chance. Your end behavior, so they are going to ask you, as x approaches infinity, or as x moves in the positive direction, what is y doing? Or what is f of x doing? Remember, f of x and y are the same thing. As x moves in the positive direction, y is approaching infinity. I'm going up and up and up to infinity. As x approaches negative infinity, so as I go to the left, y is approaching 2. -2, not +2, -2. It's getting closer and closer and closer to -2, but it never goes below -2. That's why it's not going to negative infinity, is because it's going to -2. It's never going to get past this wall. Nothing will ever be down here for this function. You could also write this, I'm just going to rewrite it so that you can see it with function notation. As x approaches infinity, f of x approaches infinity, or as x approaches infinity, f of x, negative infinity, f of x approaches -2. That's all you have to know about exponential functions. Be sure that you're comfortable with function notation. We'll talk about it a little bit in a review day as well as in video 5, but please make sure that you know function notation, especially with exponential functions.